Okay, we are live. Good evening, everyone. Welcome to the special live chat we're doing for Monday. I wanted to do it earlier because I have a lot of stuff going on, personal stuff going on for this week. I didn't want to miss another live chat. So we decided to set it up for Monday so that way we can cover over some things. There's a lot to talk about, too, in terms of the pattern, in terms of the evolution. Also, I just want to apologize in advance. I had some really good ribs, so I might burp. I don't know, but it was really, really good, and it'll prepare me for my trip that's coming up. So there you go. So definitely, just kind of give you a little warning ahead of time, because you never know. But we have a lot to talk about tonight, and then I'm going to take your questions. But I think you'll kind of get a good kick out of the things I'm going to show you to kind of explain the forecast, so looking beyond the models to explain what is evolving here. And so we're going to start off first with our La Nina data. So here is our new Enzo data. It just came out this afternoon. I'm going to walk you through this like I would in the morning because I'm going to do a rehash on this with the premium long-range thoughts tomorrow, adding in a couple more thoughts after I sleep on it. But let's take a look at the overall data. We still have a La Nina advisory in effect, which not a surprise. Very interesting to see the trends over the past several weeks. Going back all the way to last July, you can see the evolution of our La Nina. There's our first wave in the late fall and winter. Then we saw a weakening take place. Then we saw the influence of the IDO, and that's right here. And now we're seeing a weakening again. And when we take a look at the overall anomalies over the past couple of months, you can see that trend as well. So you can see clearly a steady weakening of the La Nina state in almost all the regions. Nino 1+2, which is out here, never want to use that as a measuring stick for orientation or strength. The reason why is that it's very volatile because the water is very shallow relative to the rest of the region. So Nino 1+2 is kind of like your steroid factor. If you have a La Nina, let's say if you have an east-based La Nina, and then Nino 1+2 goes super cold, then that temporarily enhances the east-based La Nina. If you have a west-based La Nina and it goes very warm or very cold, it enhances those factors. If you have an El Nino and you have a very warm Nino 1+2, it causes a basin-wide El Nino. And when you have an east-based El Nino and you get very warm anomalies, it temporarily enhances the east-based El Nino. So Nino 1+2, I like to use it as kind of like an amplifier. Okay, if you guys watch Dragon Ball, it's like going Super Saiyan for a very short period of time, right? It amplifies everything. It takes a steroid shot, right? But it's not something that's stable because 1 week you can have highly positive and the next week highly negative. This week we're highly negative after last week barely trending around the La Nina state. And take a look at this. This is 1+2 again. Look at this volatility. Look at these spikes. So that's why you never really want to trust this region. You want to stay here because long term, especially Nino 3.4, which is one of your deepest areas, is where you get your most stable readings. So you get a better idea, and the more stable the reading is, the more influence it has on the atmosphere. So let's see here. Then the departures. I like using this feature right here to get a better handle on the overall trends. And as you can see, La Nina is still very much stable and still very much influence. And then this factor here, this really kind of gives me the full picture, okay? Where you have a La Nina state, but a weakening IDO. So that's why our La Nina is weakening, but we still have a negative PDO influence here and negative AMO influence here. And that matches up very nicely with what we're seeing with the sea surface temperatures in the CFSR anomalies. What you should do is compare the different anomalies, so that way you make sure that if there's any errors or any type of missing data, you can compare the two and then find that missing data. By doing that, you become a better forecaster, because then you don't just trust one set of data. You use the comparisons and you can find the errors and then understand how those errors influence the forecast. So in this case, we continue to see cooling IDO, weakening La Nina, AMO state clearly in place, negative PDO state clearly in place. And by the way, that negative PDO state, that is bad news if you're in California, the Rockies, or the Central and Southern Plains, because that signal keeps a heat ridge in place, enhances the drought, and makes a bad situation much worse. You think that the water levels right now around Las Vegas are bad? Just wait. It's going to get worse. So right now, the trends so far are kind of moving in one direction. Could we see a reversal where La Nina gets stronger or the Indian Ocean gets warmer? I can't rule it out, okay? But the trends would argue against that right now. Let's see here. I want to get to the subsurface. Here we go. Now, I've been using the subsurface as a kind of like a canary in the mine here. Okay, so when you have this signal, this supports La Nina either developing or sustained. This signal means La Nina is weakening, possible El Nino showing up. And then this signal right here suggests La Nina is weakening and possible El Nino showing up. Okay? That doesn't mean it will. You have to take all the data in combination to make a realistic forecast. But if you're looking for signs of a weakening La Nina, this would be it. All right. Now, this is relatively new compared to the previous weeks where we saw this weakening, but we didn't have this type of sustained warmth here showing up. And you can see the trends here in the subsurface. Our cold waters are disappearing. Now, this is not an El Nino signal. I want to make that very clear. The reason why it's not an El Nino signal is that what you want to see with an El Nino signal is you want to see cold water building here and warm water building here. Right now, we're not seeing that. What this would suggest is a neutral state. Let's see here. Okay. This would give you signs of Kelvin wave influence. So you can see we're not really dealing with anything right now. You can see the influence of Kelvin waves from previous months. Let's see, it's lifting. Again, this supports our substance around the date line. This makes sense. And this is when people talk about the ION, this is the data that they're talking about. And then here is the latest CFS forecast. The IRI is not updated yet, so I'm not going to go with that. So, as you can see here, we still have support for a weak La Nina through the fall, through the early fall, and then shifting towards a neutral state for the late fall and for the winter, which, again, is going to make things very interesting for me as a forecaster, especially the seasonal forecast. This one's going to be a tough one. They're all tough, but this one's going to be tougher. Because when you have no ESNO state, that means you have to deal with the MJO. And the MJO, well, it can be pretty volatile. So I want to show you the SOI values here. Not much is changing here. What I want to do before we start talking about a weakening La Nina state on the atmosphere, what we want to see are these numbers here, this value here, start to fall off down towards like 5 and 10, somewhere in this level here. Until I start seeing that steady drop, I can't say that the atmosphere is reacting yet to these changes. So the SOI is a good way to measure the reaction of all these changes going on in the atmosphere, in the lower portions of the atmosphere. When we start to see the SOI values start to fall off towards zero, that's when we can start to say that La Nina is weakening, that we start to see a faster breakdown of ridges, and we start to see more and more of an influence of the MJO. Which leads us to this. The MJO forecast right now, again, highly volatile. We know it's highly volatile because look at all this. Look at the model solutions. They're all over the place. But what's the overall theme? That it's moving away from phase 7 and 8. It's kind of in phase 1 very weakly. But a lot of this is in a neutral state. So this tells me that for the most part, La Nina is the dominant forcing influence right now. There is sign of possibly a phase 5. But again, in that phase 5, there is a lot of volatility. Oh, there it is. Okay, so looks like unfortunately the website's a little slow tonight, but that's okay. Basically, what that sunspot is going to do is basically blow up and send an unstable beta gamma magnetic field towards the Earth. That could be an M-class. Did I froze? Can you see me now? Oh, video froze. Uh-oh. Am I unfrozen yet? Good? All right, we're back. That was fun. Okay, so where was I? Okay, you know what? I killed, you know what it is? The sun killed. This is good. This is good because what we just experienced is much like what you might experience going forward with this solar flare. I was talking about AR 3038, right? It's buffering. Well, that buffering, get used to it. That's going to be the influence of the magnetic field on the Earth. This sunspot is going to blow, and when it does, it's going to have a significant impact on our magnetic field and mess with our satellites. So just be prepared for that. It's going to be impacting over the next couple of days. If you have satellite TV, it's not going to be pretty, I can tell you that much. It's going to be rather annoying. And we also have a coronal hole facing the Earth too, so a combination of those two features. Meanwhile, our ozone has continued to plummet, but notice we're seeing a concentration in the northern Pacific, which sets up our upper level low support around the Aleutians and around the Gulf of Alaska, which sets up our trough around the west coast. Remember, the wavelengths are different in the summer. So it sets up a trough on the west coast, ridge over the Rockies and over Southern California, and sets up the potential for a nice heat ridge. And notice we have the support for our trough over the northwestern Atlantic and Canadian Maritimes and mid-Atlantic and New England. And then here's our another ridge. Now, this is interesting in this respect. All these factors that I've just broken down have a direct impact on our atmosphere. And it plays into the forecast that is going to be coming up from now all the way on through the 4th of July weekend, which I'll cover in just a moment. But one thing I want you to study here is this feature that I have up. I'm going to do a little bit of Met 101 for you. You get a free meteorology class. Okay? This is how you get a heat ridge. The reason why this is important is because what happens is that you get your initial high pressure, it has sinking air, warms the air via compression, and you get a hot conditions. That hot air expands out and then rises. Well, it can only rise so high until it starts to converge again. Then that converges and sinks, but it sinks into the already hot air. So the compression further heats, which further sets up rising motion, which further enhances the high pressure system, leading to enhanced 500 millibar heights. This process keeps going until a mechanical feature, i.e. strong cold front, tropical low pressure system, something of that nature from outside of this environment, disrupts this evolution. The reason why you need to understand this is that it is the basis of what is going to be happening over the next 15 days. And if you understand this feature, then you can weed out which models are bogus and which models make sense. And when you can weed that out, then you can generate a better forecast. But in order to do that, you have to understand the physical parameters that go about this evolution. Now, heat ridges typically are driven on land masses because it's easier to set up this process over land where it's easier to dry out, you get dry heat, and then it could feed back on itself. Can you have it over the oceans? You can, but it takes much longer to develop, and you need very warm waters, i.e. the tropical Atlantic, right? So the Western Atlantic Ridge, right? It could set up that evolution. But it's far easier to sustain over a location like, the plains, the Mississippi River Valley, locations of like that. Keep that in mind as we look at our forecast. Now, when we take a look at our satellite pictures, not much going on right now in the tropical Atlantic. Very quiet. Our disturbance that we were keeping an eye on around the Caribbean, it kind of fizzled out. Keep an eye on this activity out here over the next couple of days. Again, model guidance is starting to suggest possible some development out here over the next 7 to 10 days. Again, just possibility. And a lot of that is driven by not so much any one shortwave, but more due to the climatology of the environment and the MJO state and the La Nina state. So that's why you're seeing that in the model guidance. You have these shortwaves out here that could have potential development, and you have some favorable conditions. I would strongly suggest, as some have already made a mistake, against using the GFS at day 15 to trust any tropical forecast. You've heard me say that before, but let me reiterate. Any person who calls themselves a meteorologist and posts day 15 GFS saying, watch out for this tropical cyclone, should be immediately ignored. Because tropical cyclones are warm core lows. Warm core lows are driven by convection, and the equations to develop the convective parameters 3 days out, let alone 15 days out, is highly volatile. So I wouldn't trust that, basically. Take a look at the water vapor satellite picture. Now remember what I said about that ridge. There's our heat ridge starting to build. Here's our trough. Now why do we have this trough out here? You have this ridge here. You have a ridge out here. You have a weakness here. And you have to have a weakness here. So this is balancing everything out. This trough in evolution sets up our active pattern, because what this will do is act like a roadblock for our heat ridge. This is why I'm not expecting widespread 90s for the Mid-Atlantic. Well, at least the northern Mid-Atlantic. Because this trough acts like a roadblock, a traffic jam. It's basically the LIE of the atmosphere, okay? Nothing is going to be able to get past this trough. And that includes the heat from this ridge. And so that's why we're seeing this evolution right here. And that's why you're seeing these clouds rotate like this. And because of the convergence and confluence, that's why it was a pretty nice day. But you can see trouble back here is setting up with our warm front. So let's take a look at the model guidance. On the GFS, remember what I said, here's our heat ridge here, weakness here. What I've been saying, the weakness that's going to be focused here is a separation of the broader Western Atlantic ridge with these two heat centers. Now, if we have a feedback process, and we can clearly see that taking place here, up to about 10 days, this is in strong agreement with the European at 10 days out. Then it gets a little wonky. See this solution out here on the GFS? Doesn't make much sense. Why? Where is the heat ridge able to feed back? It's going to feed back in an area where you already have sustained heat. You don't have any type of mechanical mixing to disrupt that heat process, and the ground is very dry. Well, that isn't the southeast, that's the plains. So this looks suspect. Does it have any support? Well, let's take a look at the GFS ensembles. Do 12Z and get up to 10 days, beyond 10 days, and look at this. Now there's the GFS ensembles. Notice no huge ridge around the southeast. What does this look like? Well, take a look at this. It's almost a carbon copy, once it loads, of the European. So the GFS ensembles and the European ensembles are pretty much the same. So when you're doing a forecast and you know what the physical parameters are, and you see the two ensemble models kind of agree, this is when you have an enhancement of confidence. Okay? You can't be specific in this scenario, but what does this tell you? Well, it tells me for the 4th of July weekend that we continue to be at threat for these pesky cold fronts. So 4th of July weekend still looks very similar to the weekends we've been dealing with. Not a washout, but unsettled. Not really hot, but warm. Temperatures in the 70s and 80s. Not exactly the best beach weekend as it's sunning up right now. That could change. Just a matter of timing of cold fronts. But this pattern that's showing up would suggest the potential for, again, volatile temperature regime and an active pattern. You got your Western Atlantic ridge with the potential of transporting a tropical air mass up from the Bahamas, and you have your cold fronts coming in with influence from the Hudson Bay coming into the region. So you definitely have air mass clashes involved here. If you want to push the envelope, we'll push the envelope for you guys because I know you guys have been asking about this. So let's take a look at some of the data, and we'll jump out to the 4th of July weekend. And as you can see, it's active, but not a complete washout. So these showers, again, with a cold front on the evening of 4th of July, it could be a little wet for your fireworks. But again, this all comes down to timing of a cold front, which we all know can change within 3 days, let alone 10. Okay? So the idea here is that if you have outdoor plans for the 4th of July weekend, or really, in my opinion, any weekend, have backup plans for indoor activities or to move things indoors. Because if you're just going outdoors and that's it, you might be stuck. Okay? So just understand that is the potential there. Now, I just want to show you real fast what this looks like in terms of temperature regimes. And let me see here. Okay, so first of all, This is the new 46-day forecast from the EPS. And take a look as we go through July into early August. This right here, if you see this, this is a model error. But what stands out to me is look how similar this setup is to the setup we were just talking about. Let's see here. We'll use the GFS evolution. 15 days out, ridge, ridge, weakness. 45 days out, ridge, ridge, weakness. Literally nothing changes all the way into early August, which tells me, oh, there's our ice cream truck, which tells me, what is this, the 10th time? I think this is the 10th. This is the 3rd time the ice cream truck has gone around. Again, we have ShopRite across the street. You could buy 4 gallons of ice cream for what you pay for that ice cream truck. Doesn't make sense to me. But whatever. Notice the forecasted pattern for early August is nearly a match to the late June forecast. What this tells me is that the forcing parameters, based on the model guidance, do not change at all. Wild cards in this type of pattern, the Western Atlantic Ridge could be a little bit stronger, which pushes this trough axis a little bit further to the west, which leads to a more warmer, humid pattern. I think we keep out of the excessive heat. I'm talking about 100, 102 degree heat, stuff like that. I think that all stays in the plains. Keep an eye on the tropics in this pattern. Again, whatever I've been saying, this is a conduit for anything that enters here and here to head right up the coast. So I'm a little concerned about that. So now we got a basic idea of what to expect with our pattern overall. And I think I answered the question for 4th of July. I promised I would cover that. Again, not a washout, but be prepared. Much like for this week, with our gradient setting up here, potential for a lot of rainfall here. Take a look at this thermal gradient setting up at 850 millibars. That's impressive for this time of year. Look at this. You have your maritime air mass locked in. Here's your heat ridge. Here's your hot air trying to invade the mid-Atlantic. And it literally runs into a wall. Now this type of evolution here, boom, it just crushes any potential of hot and humid conditions for the northern mid-Atlantic, which I'm sure everyone's happy about. But this setup here sets up a potential for some rainy weather. And that's exactly what the Mesoscale data has been showing here. 18Z, we'll take a look at that, see if that's loading. And as you can see, tomorrow evening through Wednesday into Thursday, just waves of showers. Also some embedded thunderstorms. I don't think anything severe out of this. But this pattern is driven by this strong frontogenesis. Good. Here's our trough. Here's our heat ridge. We're caught in between. And your subsidence is here. So this supports your high pressure system at the surface. Your upper level low is spinning off low pressure systems out here. And then you have your heat ridge trying to build east. Bless you. And you get your frontogenesis right here. And then you have your moisture gradient. And take a look at the precipitable water values. Let's see right here. Just loads. Take a look at that. Now, when you start getting these type of precipitable water values showing up and this type of gradient, that supports easily rainfall rates of 1/4 of an inch to 3/4 of an inch per hour. And I would not be surprised if we have some flash flooding out of this between tomorrow night and Thursday afternoon. So just be prepared for that from Philadelphia to New York City. Actually, Philadelphia to Boston metropolitan area. And then for Sunday evening into Monday, or should I say Sunday morning into Monday, look at that. when you get these values of 2.5, 2.15, 2.3 in this area here, this sets up the potential for 1 inch per hour rainfall rates. This is the type of rainfall rates where you could get to flooding in New York City streets and stuff like that. So we're in for a rather wet period of weather. And guess what? It really doesn't come to an end. It just keeps on resurging. And that's essentially what we keep on seeing here with the guidance. It's just constant resurgence. We see it in the Ensemble guidance. We're seeing it in the operational guidance. A very active pattern, one that supports near to below normal temperatures, which is a bit surprising for me because I thought that we'd see more of a humid pattern, but we get warmer lows. But when you have constant low temperatures popping up into the 40s, well, that kind of shoots your forecast in the idea of having above normal temperatures. This is setting up to be a rather unsettled, cool summer because the Western Atlantic Ridge is displaced a little bit further east than I thought. The trough is a little bit deeper. The trough is deeper because the ridge that has developed in the plains has become much stronger because of the heat ridge that is acting as a feedback. So the feedback is enhancing the trough over us, which pushes the Western Atlantic Ridge a little bit further east and sets up the scenario where we remain active, but we don't get any of the intense heat. So that is pretty much where we're at now. And I'm a bit surprised with how strong the heat ridge is, which has shifted the forecast from what I thought we would see. I knew we were going to be active. I just thought we'd see more hot streaks up to this point. And thus far, we have not. So that's pretty much all I got. I'm going to go and answer your questions, and we'll go from there. So I'm going to start with the premium chat, and then we'll march our way through. So again, I want to apologize for the freezing up. I think I know what caused that. Probably when I clicked on the sun image, it kind of locked everything up. So the Atlantic is so quiet that even the GFS's convective feedback magic isn't spinning up anything tropical. It tried to 2 days ago, but yeah, I mean, it's been pretty quiet, which again is something that a lot of meteorologists were not expecting for June. There was a lot of calls for June to be a month that would feature above normal storm activity, and that just simply has not happened, which is great, absolutely great, because we don't need that. Okay, I know there's some places that need rain, but you don't need that type of rain. I can tell you that. Let's see here. Any signs that the Indian Ocean may warm back up? Nothing that really stands out. It'll probably fluctuate for a bit, but no great warming or anything showing up just yet. Of course, I'm keeping an eye on that because that would suggest a quadruple La Nina. It's never happened. So it's kind of hard to buy into that. But then again, just because we've never seen it before doesn't mean it can't happen. So we'll keep an eye on it. Is it possible that La Nina might persist with a negative PDO and AMO couplet, helping to keep it around and all three of them feeding back on each other? I did some research on this, and I looked at the data, tree ring data, from 1190 to 1220. And that was a negative PDO. It had periods of La Ninas. I also looked at the 1970s with a negative PDO state. And what happened is that after the third one, the negative PDO state still stood around, but you didn't go shifting into a El Nino. What happened instead was that you went towards a cold neutral / neutral state. So I don't think we'll see a rapid collapse in the atmospheric evolution. I think that the SOI values are hinting at that being a fact in terms of my theory. But I do think we head towards a neutral state eventually for the winter. With that said, I do think the negative PDO, negative AMO factors act La Nina-ish on the atmospheric pattern. So you'll have hints of La Nina showing up in the weather pattern, but La Nina itself will be deceased. The 850 millibar temperatures this weekend were very cold for this time of year. Yeah, let me put it this way. If not for us approaching peak sun, we could have easily been, and if not for the winds on Sunday morning, we could have been widespread 40s. These type of 850 millibar temperatures, if you maximize the mixing potential, would support lows in the 40s and highs only in the 50s and 60s. I was saying this weekend, it feels like a September weekend in mid-June. I'll take it. Run with it. You enjoy it while you can. Do you have an early forecast for 4th of July weekend? We went over that. But basically, I don't see any significant heat. I see it remaining unsettled. Very much like a carbon copy of what we're going to be seeing for this upcoming weekend. Not a washout, but if you have outdoor plans, I'd look for some backups. Amplification for this time of year is still rather impressive. I would agree. I'm trying to figure out all of the forcing mechanisms behind that amplification. There's the more active sun, which is leading to more destruction of ozone. You have a wacky La Nina influence. QBO really wouldn't have a factor. So I'm still trying to work out the forcing mechanisms that's causing this enhancement. But I think it's related to solar activity. But I'm not 100% sure yet. I'm still working on that. Does the heat ridge to the west of us amplify the northern Atlantic? Yes, it does. Remember, I'll pull up this data real fast just to illustrate. Okay. This ridge amplification, it has to have a balance in the atmosphere. The atmosphere is always looking for a balance. So you have this ridge here and ridge here. You must amplify the trough here in between. This creates a balance in the atmosphere, which as a result achieves the conservation of mass, which is a law in physics. So you have to have that conservation of mass. So you have to have a balance, because you do not just get rid of energy. You do not just get rid of mass. It just gets transferred into a different state, or it gets balanced out in a different way. The equation always has to equal zero. That's why we always have weather. It's not because of any type of voodoo. Okay, weather is simply the act of balancing forces in the atmosphere, and that's essentially what we're seeing here. Any tropical activity in Western Pacific? Nothing significant. There's a couple of tropical depressions, but nothing really to write home about. Nothing that really stands out. Wow, we have a lot of questions in YouTube land. All right, so let's go find the best one here. This is some bring in terms of severe weather outbreaks. You guys love your severe weather. Okay. In this type of pattern, I traditionally do not look for severe thunderstorms coming in via natural cold front. What you have to look for are storm complexes developing around, let's say, the UP of Michigan, northern Michigan, the St. Lawrence River Valley, portions of around Lake Erie, and those thunderstorm complexes dropping south and dropping it towards our neck of the woods. The setup that we have involved here, if you're looking for severe weather, you want to look towards eastern Pennsylvania and southwestern New Jersey in general. That doesn't mean you can't get severe weather in Long Island and whatnot, but those are your best potential areas, because those areas are most likely to be involved with more unstable atmospheres. let's see here. Is La Nina messing with our summer because it's cold at night? Not. That's a tough one. The La Nina did not cause our cold mornings, but the amplification. Okay, it did not directly cause it. La Ninas lead to more active polar jet streams. More active polar jet streams leads to more amplification. But since La Nina is weakening, I can't 100% attribute La Nina to the amplification of the polar jet stream. We also have to consider solar properties, which still have to be worked out. I'm still working out how to balance that. Will La Nina continue into the fall and winter? If so, what will it do to winter storms? I don't expect it to. I expect it to remain neutral. I expect it to trend towards neutral. In terms of impacts on winter storms, I honestly don't know yet. Because when it comes to winter storm evolution, there are far too many unknowns right now to make a guesstimate. For example, you could have a neutral state, but the MJO is stuck in phase 4 and 5 for whatever reason. Say, tropical forcing in the Indian Ocean, or mountain torque waves off of Asia. Or you could have a major stratospheric warming event take place in early December, which tanks the negative NAO and locks in for the entire winter. And regardless of the ESNO state, you get winter storm after winter storm after winter storm. All of that's on the table. Or you get none of the above, and you get a zonal pattern, and it just stays warm and boring all winter. That's my point. It's like there's too much stuff going on to know for certain. When will the hot weather come in for us during the summer? 85 plus. Well, right now, based on the data I have, maybe mid-July, maybe. In terms of 85 plus, I would assume you mean sustained. So right now, I don't see any change in the pattern. In fact, if I went with the 45-day forecast, if we went 100% trust on that, we might not be looking at sustained heat until mid-August, which, quite frankly, I'm perfectly fine with. Thank you very much. Why is this summer going to be cooler than normal in the northeast United States? What is the support for the forecast? I am predicting an El Nino next year. Well, good luck with that, Tobes. Well, I already walked through all the reasoning why. So after the video, if you want to go back and check it, definitely check that out. What does the summer early severe season for us, New England and Mid-Atlantic? What does summer and early severe season for us? That's an interesting question. Well, we're beyond an early season. We're beyond early season, severe season. I would say that overall we can expect to continue to see an active season. Does the magnitude of the sun have an effect on our weather pattern? Absolutely. Absolutely. And here's the truth. We don't know a lot yet. We're still learning so much. We have just really, really started to embark on this amazing journey of understanding all of the factors and all of the influences of the sun. We are now able to see solar flares like never before. We have imaging that we've never had before, measurements we've never had before. It's amazing. So I don't want to stand here and act like as if I know the answers to some of these really good questions, because there are scientists far smarter than me who are working on this day and night who do not have an answer. I have some theories, and they are related to ozone impact. Um, so far, they've worked out. Other winters, they have not. So there's a lot that I am learning. So when it comes to solar activity and influences on the Earth, I always put a big warning sign: high volatility, high uncertainty, because I'm working off of theories that I really haven't proven yet, but I think might work. Okay? So I always make sure I mention that and be very clear about that. And you have to understand this as well, that what I'm saying today about the sun could change drastically in 2 weeks based on the latest research. Because we're learning so much new information about the Earth's gravity waves, the influence of the sun's solar waves onto the Earth's magnetic field, the evolution of the ionosphere and solar flares and the activity of the sun and switching of polarity, all that stuff. We have theories, we think we know what's going to happen, but we haven't proven it yet. So there's a lot going on. It's an exciting time as a scientist, because the best thing that a scientist can look forward to is failure, because that's how you learn. If you're in the pursuit of knowledge, if you're in the pursuit of learning more, then you have to take your ego out and you have to embrace failure, because by embracing failure, that is how you learn. Much like with weightlifting. If you go to the gym and you never push yourself and all you do is do 25-pound dumbbell bench presses, and you can do 50 of them and never hit failure, and you feel like amazing because you never hit failure, guess what? You never grow either. The only way you grow is by failing. By failing, you learn. If you embrace the failure, you become stronger intellectually. Much like if you bench press and you fail at bench pressing 315 pounds, the next time you get that 315 pounds and you are stronger. So always embrace failure, not as a negative, but as a teaching tool. Let's see. The Weather Channel is predicting above normal temperatures again for July and August. I do not like to critique other weather companies' forecasts or analysis. I would say best of luck to them. I don't know what else to say. Oh, I see. So for early fall. Okay, so I would say early fall is kind of like a different dynamic. I think it's going to have more tropical influence. I'd be very happy if we went the entire year in our area without severe storms. Yeah, I could definitely understand that. I could go a whole year without losing power around here. That's for sure. Let's see here. Is there still a lot of Sahara dust? Actually, that's a great question. You know what? Let me pull up. Let's see here. Okay. Let me pull up some data here. Here we go. Let's take a look at this. Let's see. We can use split window. Okay. Yeah, we do. We still got plenty of dust here. All this is the Sahara dust. Let's see if we can get some better data out of this. There's our Sahara Desert. See if we can get a HTML movie out of this. It's loading. Let's see. I feel like we're getting ready for previews when I was a little kid. Ah, there we go. Yeah, it's still coming off the continent. Still coming right off. There's our desert, and there's our dust. And let's see if we could see it even better here. See, you can just see it streaming right off. So that's why the central Atlantic here is pretty much shot right now for tropical development. This dust is like the same thing as diamond dust on a baseball field. It just chokes anything that could possibly develop tropically. We have some of the heat ridge. We talked about that. Basically, as I said, if this dynamic continues to show up, then if we're going to get influence from a ridge, it's going to come in from the Western Atlantic, not from the plains. The GFS made this error. I don't like it. It isn't supported by the GFS ensembles. So I like the idea if we do get hot and humid weather, it'll be based on this Western Atlantic ridge out here building towards the coast, which would be kind of like the upper 80s to mid 90s with dew points in the 70s, which makes it feel like a sauna. So if we get that type of pattern, that type of heat, I do not see a pattern right now supportive of temperatures like 95 to 105 as high temperatures. I don't see that support right now. Could that change? Sure. But I don't see the trigger that would force that at all. Really great questions tonight, guys. Really good for a Monday. I thought, Monday, everyone would kind of be like sluggish. It's Monday. I thought I'd be sluggish and it'd be Monday, But I got the energy. I'm rolling. It's already 8:52, so we'll take a couple more questions. And then we're going to roll it out for the week. Huh?
Because you had ribs.
Yes. I had really good ribs from La Rosa. That place is outstanding. I love their ribs. I still got chicken left over too. But I'm actually full. I don't know what to do. That's crazy. No, I'm not normal. That's not fair. I've lost my ability from when I was a kid. I could eat forever, and it didn't matter. Then again, I was a teenager then, so. But yeah, I think the important lesson to take from today's discussion is the heat ridge evolution. If you understand this, then you understand why this and this is far more realistic than a ridge over the southeast. Let's see here. Is there any tropical trouble on the horizon? No, not right now. Keyword, it's early. Okay, I want to preface this. Our tropical season really kicks off in mid-July through October. Do not be surprised in August if we have like 6 named storms floating out there that we're tracking. Don't be surprised by that at all. That is a very much a high possibility. I hope I'm wrong. I don't want that to be the case, but it's a high threat. And June's usually a very quiet month. I would compare June in a tropical season to late November, early December in the winter season. Yeah, something could form, but usually it doesn't. And it's kind of a lot of waiting anticipation to see what's going to happen. I can't wait when the Yankees play the Mets. Yeah, that should be fun. I'll just put it that way. It should be interesting, that's for sure. So we got 4 minutes left, so I figure if we have any more questions, get in there. If not, we will shut it down for the week. I'll get some sleep. But I'll take your questions if there's any more left. A couple minutes. I'll wait. We might take a look at the observations. I think you can kind of see where our frontal boundary is set up here. Here's our westerly wind out here. Southeasterly wind on the coast. Southerly wind over southern New Jersey. Here comes the warmer air. You see the setup already evolving here. We are definitely going to be setting up for an active weather pattern, that's for sure. When do the Yankees play the Mets? I think sometime in July. July and August. Not too long into the NFL training camp. Yes, when the Chiefs start dominating the league again. I look forward to that. Will you make any longer videos this week? I'm pretty much going to be focusing on the traditional videos this week, for the most part. Yeah, pretty much. Unless there's something really unusual sets up. But I'm not expecting that right now. Maybe with the heavy rain event, so maybe. But I'm not really expecting that. I'm pretty much going to keep the videos separated. But we'll see how that works out. Okay, so I think we're going to shut it down for the night. Yes, Christian, we were talking about that. Definitely go back and check the video for the past hour. We've been talking about the heavy rainfall for this week. So, okay, so we're going to shut it down for the night. And thank you again for joining. I really appreciate it. The channel is becoming more and more popular each week. I really appreciate that. I expected it to just be crazy this winter, so that should be fun. But thank you for spending your time on a Monday evening. I really appreciate it. And as always, stay safe out there.